Alright, so I want to talk a little bit about flat and curved surface reflection. How do you exactly find that if you're not too keen on it? So what I'm going to do is just make a mirror. This is a flat mirror right here. And what if I had some random ray coming in and striking my mirror? We'll call this the incident ray. So what happens? Well, this incident ray is going to bounce off my mirror. So what it's going to do is I have a normal here, and whatever angle this is, it's going to bounce off at the same angle. The angle of incidence will equal the angle of reflection. But I have to find that kind of a little bit more specifically than just kind of guessing. So the way we do that, a good way to do it is using our compass. So what I'm going to do is I'm just going to open my compass to some random angle, place the pointy part there at the intersection, and then scribe a couple of lines. Now, after I make those intersections, what I'm going to do is open my compass just a little bit larger. And I'm going to come up here and I'm going to make an arc, and come over here and make an arc. And where those two intersect, if I connect this to here, this is my normal. So this is the normal. So this angle right here is the angle of incidence. So I have to copy that angle and make the angle of reflection be the same as that. So what I do, I take my compass again to some random angle, put it here, and I'm going to strike myself an arc. And now what I'm going to do is I'm going to measure this sector right here, programming it essentially with my compass. So then I come over here and do it, and I make a tiny mark right there. So then this is where my reflected, so this will be the angle of reflection. So the angle of incidence should equal the angle of reflection. That's the law of reflection. Says that the incident angle equals the reflected angle always. So that's how you find reflection off of a flat surface. Now, what if you had a curved surface? So what if I had a mirror that was, now watch this, I'm going to put my point right in the center of my E. So let's say I've got a mirror like this, that's a curved mirror. And what if I had a light ray, in this case, comes in, strikes it like this. This is my incident ray. How do I figure out how it bounces off here? Now, it's really nice. There's two things. Remember how I put the center right here? Well, if I know where the center is, this is really simple. All I do is I would connect here to here like that. That's the normal. This would be a right angle right there. And then I would do the exact same thing as what I did before. Copy this angle. This would be the angle of incidence. Copy down the angle of reflection. But I don't know that center. What I'm going to do is go through that same process with my compass. So I open it up to some random sector. I'll put a dot. Make another mark like this. Open it up to a larger sector. Strike an arc. Strike another arc. Now all I do is connect this to there. And you'll see, if you look close enough, I can see because I'm right on top of this. This is right over top of this. If I extended this, check this out. It goes right to the center. So now I just have to copy my angle again. So again, here's the angle of incidence. Now to copy that, I strike myself an arc. I'll measure this distance. Right there. And now my reflected ray goes out there through that. And then this is the angle of reflection. Again, angle of incidence equals the angle of reflection. That's the law of reflection. So that's off of a curved surface. And you can see they're both pretty much the same. I go through the same steps to do both curved and flat. Now this only works for spherical, this method with my compass and protractor. It doesn't work with a parabola. Parabolas, you need a little bit of math to find the slope of the tangent and then to find the inverse of that slope to find your normal.